Hey everyone, this is Big Face from Big Face Robotics. I'm carrying on the work on the RC robot. It's stripped down a little bit at the moment because I'm going to be adding some more sensors. You remember from the last episode I had the webcam and Raspberry Pi mounted on top of the robot capturing some video, but I wanted to take this opportunity to add a couple of sonar sensors and an MPU6050 accelerometer gyroscope unit to the robot as well. So the robot's in pieces. I've popped the Arduino board out and let's have a look at what I've needed to do to add these sensors in. So here we go, I've taken the control board off of the robot for now so that I could add in a few extra connectors for the additional sensors. I'll just go through what's on the board currently. I've got an Arduino Nano and interfaces for the various sensors, outputs to the L298 motor driver, and inputs from the encoders on the motors. So you can see I've added a couple of sonar sensors. These are SRF05 sonar sensor modules and the 3D printed brackets for attaching them to the robot. So I printed these up, pretty simple, and I'm going to mount two sensors on the front of the robot, pointing forward at 45 degrees for now. Hopefully that'll be sufficient to detect obstacles in front and to the side of the robot. These are pretty simple to interface. It's just a 5-volt supply, ground, and a signal back to the Arduino, and a little bit of code to read the distance values from the sensors. So I've also added the MPU6050 module to the underside of this bracket. So this will give acceleration and gyroscope outputs, and also with a library on the Arduino you can also read roll, pitch and yaw values from the module as well. And this is interfaced to the I2C bus on the Arduino Nano. Currently I have the Bluetooth module, the HC05 module interfaced to the Arduino, and I'm thinking about moving that to the Raspberry Pi. I think you can have that interface to the Raspberry Pi. And as the Pi is on the robot anyway, I'm thinking of having that take inputs from the controller and send those commands through to the Arduino to control the motors and read the sensor readings back. So I've updated the circuit diagram for this in Fritzing. I'll put that up on the screen now for anyone that's interested in what the circuit currently looks like. Okay, so you can see I've got power onto the board. I've just got some code running on here to read the two sonar sensors and grab some data from the MPU6050 module and display it on the screen. So you can see the left and right sonar value, and I'm just displaying the yaw value from the MPU6050 for now, just as a test. And you can see a counter that's just counting up for each read of the data. So you can see the left sonar value changing as I move my hand in front. The right's working as well. And if I move this bracket that's got the MPU6050 mounted underneath, you'll see the yaw value changing as well. And it's a pretty stable value. So I'm happy with that, that's all working. I'm going to put all of this back into the robot, hook it all back up, and then add this code to the main code for the robot, and do a bit more testing. So there we go, the two sonar sensors are mounted. Pretty straightforward job, just a few holes to drill in the base plate there, and I can start putting everything back together. I have noticed something though. I decided to give the worm drives a good looking at while I was putting everything back together. I don't know if you can see that, but this is something I quite often get with 3D printed gears like this. Can you see the cracks starting to form around the securing screw there? And a similar one on the wheel hub. Now, I normally combat this by making the hubs, these bits here, as thick as I can to take the force. It's not normally the force of the gear doing any driving. It's normally the force of tightening that screw up there to keep the gear on the shaft, which causes the damage, and it splits along the print lines. So that's something to look out for. I think it's okay for now, it seems to be doing the job, but one to watch out for, and bear in mind if you're designing anything similar. I've popped a bit of super glue in there for now and hopefully it will hold up, but yeah, one to keep an eye on. So I'll continue putting everything back together. So the front end of the robot's all reconnected, control board and everything. The Sonar sensors are wired up, and you can see the MPU6050 module tucked in under there out of the way. So I'm going to move on to a bit more work on the Raspberry Pi, and we're doing that next. I'm moving the HC05 Bluetooth module from the Arduino to the Raspberry Pi. If you had a more modern Raspberry Pi, a Model 3 or 4, the onboard Bluetooth would do this job, but I haven't, and I'm not going to buy a new Raspberry Pi for a minute, so I'm going to reuse the module that I've already got. Pretty straightforward job to hook this up. It's just a 5V and ground connection out to the module, and the receive and transmit pins on the module are connected to the receive and transmit pins on the GPIO. But you have to flip them. So receive connects to transmit, and transmit connects to receive. I'm going to mount this onto the case just like this, and I've 3D printed a nice little housing for it, and I'm going to glue that to the case, and the module just clips in, and you'll see it's actually a nice 3D print, because when you put the module in you get a nice satisfying click, and it's in there and it's not coming out in a hurry. So I'm going to glue that to the case, and that's that mounted. So there we go, that's stuck onto the case there, nice and secure, and that's ready to go for now. The idea being that the signals, or the data from the controller, from the joysticks, will now be received by the Raspberry Pi and then sent on from the Raspberry Pi to the Arduino to do the motor control and read the sensors. And in the meantime, the Raspberry Pi will also be reading the data from the encoders and sensors back and storing it in a file as the robot drives along. Because what I want to do is, as I was doing with the video capture, the frames of video, I also want to be logging the robot direction, encoder counts and sonar sensor values. So the next job is to get some software written to do all of that. Okay, so first modification to the code is pretty straightforward. I just need to change the Arduino to be looking for data from the serial port rather than from a software serial port, which the HC05 was connected to. So you can see I've got the serial monitor running, and I've just changed the serial port that it's reading from, and I can type in commands and start up the motors from the serial monitor. So all the Arduino is expecting is an X and Y value that relates to the position of the joystick that the remote control Arduino is sending out. Now all I need to do is modify the code running on the Raspberry Pi to read that data and send it on through to the motor control Arduino. Right, so here's the setup. We're doing a bit more work. I've got the Raspberry Pi with the Bluetooth module attached. I've got the controller sending out serial data of joystick positions via its own Bluetooth module hidden in there, and then the Raspberry Pi is connected via USB over to the Arduino on the robot itself. So as I'm moving the joystick, this is the serial data that's being received by the Raspberry Pi, so this is what's running on the Raspberry Pi at the moment. And you can probably hear when I move the controller, the robot wheels are moving. So that's all working. This might seem like a bit of an over-the-top way of doing it, or a bit more complicated than it needs to be. But what I want to be able to do is remote control the robot, and as it's driving around, capture images from the webcam, but also log the sensor data from the robot onto the Raspberry Pi as well. So I thought if the Raspberry Pi is receiving the serial data from the controller and sending that out to the Arduino on the robot can also send that serial data back to the Raspberry Pi for it to be logged into a file. So I haven't got quite as far with this as I'd have liked, and I'm worried that it's been a little while since I've put a video up. So I'm going to wrap this one up for now. But what I have managed to get working is some data back from the Arduino on the robot back via the Raspberry Pi and displaying on the screen that is connected to the Raspberry Pi at the moment. So as before, I've got the transmitter here, I've got control over the robot wheels, and I managed to get some strings of data back. If I set the robot going forward, you'll see the last two numbers change, which are the wheel encoder counts and backwards. And I've got the Sonar and yaw value from the MPU6050 coming back as well at the moment. So not complete. I haven't got the login to file bit working yet. That's going to be next, but I do want to just wrap this video up. So there we go. The next video I'll have the robot driving around again and logging some data into a file which I can then grab and do some further processing on. So that's where we are at the moment. So as always, thanks for watching, and please like and subscribe if you enjoy my videos, and come back soon for the update.